The 14th question says, find the coordinates of the foot of perpendicular from the point this to the line this. Okay, foot of perpendicular from the point this to the line this. Pretty interesting, very important question, right? So if this is line L is given to be 3x minus 4y minus 16 is equal to 0, and this is point P, let's say, which is minus 1 comma 3. What are we asked? We are asked to find this foot of the perpendicular M. Okay, we are asked to find this foot of the perpendicular M. Let's denote M by h comma k, and we'll find h and k, right, somehow. Okay, one particular result is a direct result which we can follow and which we can use to find the foot of the perpendicular easily. I'll explain that formula first, and then we'll solve this question using basic concepts, right, basic methods. First let's solve using basic concepts, and let's verify after that using the formula. Okay, we'll verify later on. Okay, let's forget about this formula first. Let's solve using the basic concepts. What are that? Because NCERT people want this kind of a thing. Coordinates of the foot of the perpendicular from the point this to the line this. Okay, so we need h and k. There are two unknowns, right? And for solving for h and k, you will need two equations maybe. So one of the equations can be directly seen that M point lies on this particular line. Therefore, 3 times h minus 4 times k minus 16 is equal to 0. This is equation number 1. It's okay. Another equation that you can observe is this is perpendicular, right? So M of PM, the slope of this PM times the slope of line will be equal to minus 1. That's what you can observe, right? If this is slope of L and this is PM, slope of PM. What is slope of PM equals to? Slope of PM will be k minus 3 upon h plus 1. This is the slope. What is slope of L? So for that we can write it in the slope intercept form. This is 4y is equal to 3x minus 16, or y is equal to 3 by 4x minus 4, and this here is the slope. 3 by 4 equals minus 1. And on rearranging this, what do we get? This will further tell me that 3k minus 9 is equal to minus 4h minus 4, which tells me 4h plus 3k and minus 5 is equal to 0. This is equation number 2. Yes, this is what you get. 4h plus 3k minus 5 is equal to 0, and you had 3h minus 4k minus 16 equal to 0. This is equation number 1. Okay, can you solve these two equations to get the values of h and k? Yes, we can solve these two equations to get the values of h and k easily. For that, okay, one of the approaches which you can follow is elimination, the other is cross multiplication. And what would I like to use? This is 3, this is 4. So let's multiply equation 2 by 4 and add with equation 1 multiplied by 3. Okay, equation 2 multiplied by 4, this becomes 12, and this times 3 becomes 12 over here. Adding them will eliminate k. Okay, and what will this become? This is equation 2 multiplied by 4, 16 plus 9 is 25h, and as k is gone, you get minus 20 and minus 48 is equal to 0. This is what I am getting, right? This tells me h will be equal to 68 upon 25. H comes out to be 68 upon 25. Pretty interesting. Let's check the value. Okay, 68 upon 25 once. So what I'll be getting is, this is 4 times this is 20 and 3 times this is 48. So adding them will give me minus 68. Yes, and 68 will go on that side, and this is what you'll be getting, right? These equations seem correct. That's not an issue. This is correct for sure because we have noted the equation of line properly, and if the slopes have been noted, k minus 3 h plus 1 times 3 by 4 is the slope. So 4h plus 4 with a minus 3k minus 9, 4h plus 3k becomes 5 on the right hand side, or minus 5 over here. And that's also correct. So everything seems correct. H is equal to 68 upon 25. What's the value of k? K can also be found using any of these equations, or for that matter we can use a similar idea here. That is, we can multiply this by 3, we can multiply this by 4 and subtract. Okay, so multiply equation 2 by 3 and subtract equation 1 multiplied by 4 from here. Okay, this times 3 is 12h and this times 4 is also 12h. They will get subtracted. This times 3 is 9 plus 16 will be 25k. Next we have minus 15, okay, and 1 into 4 will be 64, but there is an extra minus over there, so that becomes plus 64, okay, equals 0. On the right hand side you have a 0. This gives me k equals 64 and 15. That will subtract to give me 49, and this becomes minus 49 upon 25. Okay, so the vertex, the coordinates of M will be 68 upon 25 comma minus 49 over 25. That's what you have, right? Okay, this is using the direct approach, and we can also get the same result using another approach. What's that other approach? Using a direct formula. As we discussed, we'll say spend some time on that as well, right? So in case you have any line ax plus by plus c equals 0, and you need for this point p x1 y1, if you need this perpendicular distance d, sorry, not this perpendicular distance d, if you need the foot of perpendicular, right? If you need the foot of perpendicular, this m, let's call this x2 comma y2, if you need the coordinates of m. So the direct result which says that x2 minus x1 upon this upon a is equal to y2 minus y1 upon this b is equal to minus 1 times what you have is ax1 plus by1 plus c upon a square plus b square. Mind you, there is no modulus, there is no under root in the denominator. This is the result that we can use to get foot of the perpendicular directly. This is a result that we can get to use to get the foot of the perpendicular directly. This expression can be calculated with the help of this and this, and using this with this we get x2, using this with this we get y2. This is x2, this is y2, we can calculate and check, right? This is something which you can do on your own, and yes, this is the final answer for this particular question, as you can see behind me.